Welcome to the Unit 6, Section 5 video on solving by elimination. Another method for solving systems of equations is elimination. Like substitution, the goal of elimination is to get one equation that has only one variable. Remember that an equation stays balanced if you add equal amounts to both sides. Consider the system that is presented here. Since 5x plus 2y equals 1, you can add 5x plus 2y to one side of the first equation and 1 to the other side, and the balance is maintained. Because whatever you do to one side, you have to do to the other. But if two things are equal to one another, then if you do one side of an equal sign to one side and one side of an equal sign to the other side, you're still maintaining that balance. Because essentially what we're doing is we're adding 1 to each side. It's just that 5x plus 2y is equal to 1. So we're substituting 5x plus 2y in for 1 on the left-hand side. And when we do that, since negative 2y and 2y have opposite coefficients, you can eliminate the y by addition by adding the two equations. The result is one equation that has only one variable, 6x equals negative 18. When you use elimination to solve a system, align all like terms in the equations. Then determine whether any like terms can be eliminated because they have opposite coefficients. So to do this, you're going to write the system so that like terms are aligned, eliminate one of the variables, and solve for the other variable. Substitute the value of the variable into one of the original equations and solve for the other variable. Then write the answers from steps 2 and 3 as an ordered pair, x, y, and check. So let's use elimination to solve the system of equations here. So what you're going to do first is you're going to write the equations in column form, and then we're going to add them because we have negative 2y and positive 2y. And when we do that, we're going to get x plus 5x, which gives us 6x. Our two y's cancel, and we have negative 19 plus 1, which is negative 18. So notice that the variable y is eliminated. So that allows us to solve for x by dividing each side by 6, which gives us x equals negative 3. Now that we have negative 3 as our value for x, we're going to substitute it into either equation and find the value of y. I will always suggest use the equation that looks easier to work with. In this case, x is all by itself in the first equation, so I'm going to plug it into the first equation, add 3 to each side, and then divide by negative 2 to get y equals 8. So now that we have an x value and a y value, you can write the solution being negative 3, 8. When two equations each contain the same term, you can subtract one equation from the other to solve the system. To subtract an equation, add the opposite of each term. So for example, let's use elimination to solve this system. First, you're going to stack your equations like you did when you used addition, but you'll notice that 4y and 4y have the same sign, so we need to subtract. Well, remember, subtracting is like adding the opposite. So I'm going to change from subtraction to addition, and I'm going to flip the sign of every term in my second equation. So negative 2x becomes positive 2x, positive 4y becomes negative 4y, and positive 8 becomes negative 8. Because subtracting negative 2x is the same as adding 2x. Subtracting positive 4y is the same as adding negative 4y, and subtracting 8 is the same as adding negative 8. And then from here, we can add 3x plus 2x, which gives us 5x. Our 4y terms cancel, and then 18 plus negative 8, or 18 minus 8, gives us 10. Divide each side by 5, and you get x is equal to 2. Now substitute 2 for x in either equation, which I am going to go with the second equation in this case. You can do either. Both are going to get you to the same place. Substitute 2 for x. Negative 2 times 2 gives you negative 4. Add 4 to each side to get 4y equals 12. And then divide each side by 4 to get y equals 3. And so our solution is the point 2, 3. In some cases, you will need to multiply one or both of the equations by a number so that one variable has opposite coefficients. So in this example, we are going to use elimination to solve this system. If we stack them, you'll notice that we don't have the same coefficients on either the x or the y terms. So to correct this, we're going to multiply each term in the second equation by 2. Remember, whatever you do to one side of an equation, you do to the other, and everything maintains its balance. So we're going to multiply the left and the right side of the second equation by 2. This gives us 2x and negative 2x, which can cancel. Our y's add together to give us 7y, and then 3 plus negative 24, or 3 minus 24, gives us negative 21. Divide each side by 7, and you get y equals negative 3. And now we just take negative 3, plug it into one of our original equations. So I'm going to choose the first equation. Again, you can choose to do the second equation. It doesn't matter. You're still going to get the same result. So we'll plug in negative 3 for y. That gives us 2x equals 6 when you add 3 to each side. And then divide each side by 2 to get x equals 3. And so our solution here is the point 3, negative 3, our x and y values as an ordered pair. Let's take a look at this system. We stack it, and again, we cannot eliminate anything, but we can multiply the first equation by 2 and the second equation by negative 3. Because if we multiply the first equation by 2, that takes our y term up to negative 24. If we multiply the second equation by negative 3, our y term becomes positive 24. And then we can get those variables to eliminate. So we're left with 14x minus 15x, which is negative x. Negative 44 plus 42 gives us negative 2. And then multiply each side by negative 1 to get us x equals 2. Now we're going to substitute 2 in for x into either equation. We'll just choose the first one here. Put 2 in for x. 7 times 2 is 14. Subtract 14 from each side, and you get negative 12y equals negative 36. And then divide each side by negative 12 to get y equals 3. Substitute 3, or actually we're done. We've already done the substitution, so our solution to the system is 2, 3. We have our x value, we have our y value, we are finished. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.